Alright, let's look at section 2.3, number 54. Alright, so this is a third order Euler equation, so we're going to use the substitution. Let v equals natural log of x. Alright, so let's try that. Alright, first we can take the derivative of this guy, dv over dx is equal to 1 over x. Right? Then we can figure out y prime. Y prime is dy over dx. Right? But we're going to try to do it with respect to v, so we can write it as dy over dv times dv over dx. Right? Then you can see that 1 over x can be plugged in here, because dv over dx is 1 over x. So what you get is 1 over x. I'm going to write this guy first, then times dy over dv. Alright, then similarly we can do y double prime, which is going to be we can just take the derivative of this guy with respect to x, but we're going to take the derivative with respect to v first. So let's say so this is going to be, I'm going to take the derivative with respect to x. Right, so it's a 1 over x dy over dv. Alright, so this is a product rule, so this is a multiplication. So derivative of 1 over x is negative 1 over x squared, then times the second guy dy over dv, right, plus I leave the first guy as it is, 1 over x, times derivative of dy over dv with respect to x. We can take the derivative with respect to v first, so we can just do a second derivative of y with respect to v, but we have to multiply by dv over dx. Right? Again, we can plug 1 over x into dv over dx. So you can see that here there's 1 over x and another 1 over x. So both of these terms have 1 over x squared. So I'm going to pull out 1 over x squared. Right? Then I'm going to write a second derivative of y with respect to v first, then minus dy over dv. Right? Alright, so that's the second derivative, and we need the third derivative, so we're going to do it again. So y triple prime is equal to, alright, so we're going to have to take the derivative of this guy. Right? We need a bracket there. Right, we put a bracket there, 1 over x squared, and times second derivative of y with respect to v, right, minus derivative of y with respect to v. Right, so product rule again. Right, so I'm going to just, let's see, derivative of 1 over x squared would be, let's see, x to the negative 2 power. So put the negative 2 in front and subtract 1. So x to the negative 3 power. So it's going to be x cubed on the bottom. Right? Then times exactly the same thing. So second derivative of y with respect to v minus dy over dv. Right? Plus, right, leave the first guy alone, so you have 1 over x squared, right? then we have to take the derivative of these guys. But remember, we're going to take the derivative of this guy with respect to v first. So we have a d, so this is a third derivative of y with respect to v, right? But we have to multiply by dv over dx, which is 1 over x again. So what I'm going to do is I'm going to just be a little bit lazy, and I'm going to just put the 1 over x right here. So it used to be 1 over x squared, so I'm going to turn it into x cubed, 1 over x cubed, so that 1 over x is incorporated there. Right, same thing with the derivative of this guy. So this is going to be a minus second derivative of y with respect to v times dv over dx is already incorporated, right? So we have that. Alright, then if you want to clean up, we can do that by, let's see, we can just go here, right? So 1 over x cubed is in common, so I'll pull that out. Alright, then what we're going to have is, let's see, let's find x, the third derivative. So this is the only third derivative right here. Right, so we have a third derivative of y with respect to v, right? So that's taken care of. And then a second derivative is right here and also right there. So you can see that you have a negative 2 and a negative 1. So it's going to be minus 3 second derivative of y with respect to v, right? And then we have a last one, so this guy right here. Right, so this is going to be a negative negative, so plus 2 dy over dv, right? So that's everyone. Alright, now we can plug all these guys into the original equation. Right, so you can see that here, if you plug in y triple prime, conveniently we have 1 over x cubed, so that will cancel with this guy. So you have, let's see, I'm going to just, so I'm going to go from here and there, right? Actually, I went outside. Here, so you're going to get third derivative of y with respect to v. Right, so that's this guy right here. These are canceled out, and a minus 3 second derivative of y with respect to v. Right, plus 2 times dy over dv. Right. Right, then we plug in the second double prime, so we plug in double prime, so x squared cancel out, so you have a 6 times those guys, so it's going to be plus 6 times second derivative of y with respect to v, and a minus, because of the negative sign here, 6 dy over dv, right? Then we plug in y prime, so x's cancel out, so it's going to have plus 4 dy over dv. Right? So we have that, and then this is going to be equal to, oops, right, this is going to be equal to 0. Right? Alright, then we can simplify a little bit. See, if you collect the like terms, let's collect the like terms. Here we have, so this is only 1. So I'm going to just write that down. So this is going to be a third derivative of y with respect to v. Right? And collect like terms, so it's a second derivative, so it's a negative 3 here and a positive 6. That seems to be it, so it's going to be plus 6 second derivative of y with respect to v. Right? Then but you can see that you have let's see, positive 2, negative 6, positive 4. So these actually cancel each other out, so they're gone. So we have this is just equal to 0. Alright, then we can see the characteristic equation. So look at the characteristic equation, which is going to be r cubed minus plus, oh actually I messed it up. This was right here. This was actually negative 3 plus 6, so that should have been 3. Right? So you have a 3r squared, right? Which we can factor out the r squared, and r plus 3 equals 0. Right? So therefore, our value is going to be, right, r is going to be 0 with the multiplicity 2 and the negative 3. Right? So we know the solution, solution y, so this tells you, I'm going to actually go up here. Alright, solution y can be written as, alright, so it's going to be c1, e to the 0 is 1, and since it's repeated, so you're going to have c2, remember that the variable is v, so it's v, and then plus c3 e to the negative 3v. Right? Then what we need to do is we have to actually put the original variable. So v is natural log of x. So this is c1 plus c2 natural log of x plus c3 e to the negative 3 natural log of x. Right? Then we can actually put the negative 3 up here, and also exponential function and a log function cancel out. So what you get is, alright, so this is a final solution. So y is equal to c1 plus c2 times natural log of x plus c3 x to the negative 3. Right? So that's the solution, general solution to the original Euler equation. Right? That's it. I hope that this was clear.